Hello, my dear students. Good evening, everybody. Welcome back to your very own faculty driven institute resultant. Guys, be quick and kindly join the session fast. Come on, guys, so that we don't waste time. Come on, be quick. Okay, so now we will be starting with the session. So let's not waste time and let's be very quick. So first of all, you know that it's your very own faculty driven institute. And guys, if you are don't know about me, then you can go through my profile as well. And guys, you know, or if you don't, then let me tell you, we have launched the crash course and we are offering 320 plus hours of live session along with study notes, PYQs, formula notes, and test series. Okay, right now the offer price is 7,999. Apart from that, if you talk it about, if you need any sort of guidance, any doubts, you can mail us support@resultant.in. For civil, you can contact Abhinav sir. For mechanical, you can contact Dheeraj Sardana sir. Apart from that, this is our team for GATE Civil Engineering. And guys, if you start your preparation journey with us, you will be getting live plus recorded classes, which you can access a number of times. Apart from that, PYQs, question banks, doubt sessions, and test series. Fine. So now we will be starting with the session quickly without any delay. So let's be quick and not waste time. Fine. Okay. So the first question with you, I'll be taking only 5 questions. We'll complete it in half an hour. We'll not exaggerate it and extend it for without any reason. Okay. So first question is for you, and this is an MSQ question. Okay. Why am I? This is going like slanting. Just a minute. Question number one, and this is an MSQ. Fine. A concrete surface is exposed to seawater spray, corrosive fumes, and reverse freezing conditions. Here, find out the minimum bags of cement required for the construction of 5 cubic meter of footing. Okay. Now here when it has told you this one and it is asking you that how many bags of cement is required for your RCC and for your PCC. Okay, so let's talk about it. Now guys, this is an MSQ question, so more than one options can be correct. But first you have to figure it out that what should be the number of bags of cement required. But before that you should know the type of conditions which it is exposed to. Check it out. Exposed to seawater spray, corrosive fumes, reverse freezing conditions. That means it is what? Severe condition. It is what? Severe condition. Now, if I proceed further, anybody has solved it? See, if you know and if you can approach to it, then you're free to do it. Okay, so no foundation from my side. But if you're free and if you want to start yourself first, then definitely you can start first by yourself. No issue from my side. Huh? Okay. So guys, for this now the given condition for you, condition given is severe. Okay. Now we need for PCC and RCC. Can anybody tell me for PCC how much minimum cement is required? Come on. Anybody? For PCC, how much minimum cement is required? See, you should know how much minimum cement is required for PCC and required for RCC. Anybody? Nobody? Okay. This is 260 kg per cubic meter. How much it is asking for 5 cubic meter? So 260 into 5. This will become how much? 260 into 5, that is 1300 kg. Now you know one bag of cement weighs how much? 50 kg. So number of bags of cement, 1300 by 50. 50. That is 26. So for PCC, the number of bags of cement required is 26. So C is the correct one. Now for RCC, can anybody tell me how much minimum bags of cement is required for RCC, guys? Anybody? See, at least these data you should know. Like minimum cement required for PCC, minimum cement required for RCC. These are the basic things which you should know. Now for RCC, minimum cement required 340 kg per cubic meter. So 340 into 5, that is 1700. So number of bags of cement is 1700 divided by 50. That is 34. So for RCC, how much it is required? 34. Okay, so for this question, the question is very simple. Only thing which you need to know is how much cement is required for PCC and how much cement is required for RCC. That's it. Other than that, nothing was there in the question. Okay, is this question clear, everybody? Is this question clear? Fine. Okay. Now we'll move to the next question. Now see here. An RC beam is given to you. Effective span is given to you as how much? 6 meter. And here it is subjected to a fact. Already it has factored. Dead load is given as 10 kilonewton per meter. Live load given as 12.5 kilonewton per meter. Okay. It is asking you the bending moment M2. Come on, guys. Now for this, you should know the coefficients. Then only you will be able to solve. Otherwise, you won't be able to solve. That is the thing. Come on, come on. At least try. See, obviously, I'll be telling you for sure. But when I'm talking about challenging questions, so it's like first you should also apply your brain, na? Dead load. Effective span, everything it has given. So you don't have to worry. Come on. Tried? See, you already might be knowing about like dead loads, length square, live load, length square. You should know the coefficients. That's it. Only thing is you should know the coefficient you have to substitute. You know, for support moments, the support ends, the coefficient is different. For end spans, the coefficient is different. Come on. Span moments, support moments. What will be the coefficient? This you should know. See, it's not mugging up. I tell you that instead of mugging up, practice 4-5 questions related to it. Automatically, it will be going into your head. Anybody coefficients? Plus 1 by 16 plus 1 by 12. These both will be in plus. Okay, everything is given to you. Just substitute it. 1 by 16, 10. Length. Length is 6 square. 1 by 12. 12.5. 6. That's it. So this coefficient 1 by 16 and 1 by 12, these you should know. Okay. So now let's start. Okay, this comes out to be 60 kilonewton meter. This is not more than 1 marks question. This is your 1 marks MCQ. Again, this was your 2 marks MCQ. And see, every question is different from another. You won't be getting repetitive questions like the same question. I'm just changing the data and giving you. No. You'll be getting different questions of each and every type. Clear this question? Now, let's move to the next question. A haunched varying depth reinforced concrete beam is simply supported at both ends, which is shown to you. Okay. Beam is subjected to a uniformly distributed load of 10 kilonewton per meter and the span is 20 meter. Okay. It is asking you shear force at 5 meter and it is mentioned to you in which side it is asking to you. So come on guys, first you have to calculate as the protocol and then I'll do it. Come on. At least try, which I always say that you should try. Whatever happens, but you should be the one who should apply your brain. Come on, quick. See, first you can calculate. See, what you need in this question, start from the backward direction. If you don't know how to proceed, what to do, start from the thing which it has asked you in the question. It has asked you shear force. If it has asked you shear force, how can you calculate? It will be design shear force is equal to tau v into BD. Correct? Width is known, depth is known, only tau v is to be calculated. Now, this is the case of varying depth. For varying depth, what you get? M by D tan beta. Correct? So first you need to calculate shear force at 5 meter. You need to calculate the bending moment. You need to calculate the tan theta and tan beta. That's it. You are good to go. So this is the one. So when you're not able to know from where to proceed, start from the backward direction. What it has asked you in the question, start from that side. Okay. Now from here, if I talk it about 10 kilonewton meter, this will become how much? 20 into 10 by 2, WL by 2, WL by 2 both the sides. So from here it will become how much? 100. Support moment will become how much? 100 kilonewton. Correct? So now if I need shear force, what it will be? Now this shear force and all you can calculate. And now don't tell me that you cannot calculate shear force also. 100, this is acting in vertically upward direction minus the UDL which is acting in downward direction. How much? 10 into 5. So this will come out to be 50 kilometer. Now talking about the bending moment at 5 meter. So 100 into 5 moment due to this reaction minus this 10 kilonewton which is acting, 10 into 5 into 5 by 2. Now let's solve this. 500 375 kilonewton meter. Now talking about just the angle. Okay, so tan beta. Now this whole depth is 600, this is 400, so this one will become how much? This much depth will be 600 minus 400. Correct? This one 600, this is 400, this is 600. So this starts from here. Okay, for this angle. So 600 minus 400, this one will become 200. And the depth is 400. So till the center, the span will be how much? 10 meter. 10 meter means how much? 10 meters in mm will be multiplied by 1000. Okay, because 400 mm is you are getting it at the center. Okay, so from here, how much is coming? Let me keep it this much only. I'll do it at the in the end. Why to convert it into decimals and basically make the quotient complicated. Okay, now let's substitute the values. VU is coming out to be 50. Let's take everything in kilonewton. Right now this is in kilonewton. Moment is in 375. Tan beta both are in mm, so doesn't matter. 200 by 10 into 10 raised to power 3. Width, if I talk it about. Now what the width you will be taking, guys? Come on. What is the width you will be taking? At least answer. It's okay that if you are not able to do whatsoever it is, but at least answer. At least a part of it you should be able to answer. No? See, I'll be calculating only tau v BD. I won't calculate the BD also. Why? Because anyways, I don't need to calculate the shear stress. It is not asking you in the question shear stress. It is asking you design shear force. Since it is asking you design shear force, which is tau B into BD. So why to waste your time that first divide by BD, then multiply by BD. You don't have to do it in your scientific calculator, that it can be done within a fraction of seconds. Okay. So now what will be the D value? Depth will be how much? 0.5. Take that. Okay, now come on, solve this. 50 plus this will come out to be, oh, last question also I guess it was 65, no? 65, because I got tau VD, which is your what? Design shear force. Correct? So this will be your what? Design shear force, that is VD. Okay, fine. Now let's talk about the next question. Question number 4. Any doubts in this question? Is it clear to everyone? Is the question clear? Okay. Now let's start with the fourth question. As per IS 456-2000, bond strength of concrete M25 is given to you as 1.4 megapascal. Fe415 grade we are using, that means HYSD we are using. Bars are under compression. 3 bars are bundled together. It is asking you the development length. Now, how will you calculate? See, a compression, you know that we multiply by 25% increase is there. For HYSD, 60% is there. But here, actually, the next thing which is mentioned apart from the things which you do every time is 3 bars bundled together. That is the thing which is given to you new. So, how will you calculate the development length? Come on, quick, quick, quick. See, this is the second last question. Let's be quick. This is phi, the dia phi. You can write 5 sigma st upon 4 tau bd, or you can write 0.87 fy 4 tau bd. Correct? Now what we are using? We are using Fe415. Now what is happening is bars are under what it is mentioned to you. Bars are under firstly HYSD 1.6. Bars are under compression 1.25. Apart from that, what else you will do? What else you will do? Tau BD is given to you. Now, what you will do? 3 bars bundled together. Anybody? 3 bars bundled together. You will increase 20% increase will be there. Due to 3 bars bundled together. Okay, so now 0.87 into 415 4 into 1.6 into 1.25 into 1.4. Apart from that, 20% increase is there. That means 1. This was the thing which you need to know in this question. Other than that, nothing is there in this question. Okay, so now let's start. 0.87, 415, 1.2. 38.683, and this phi is there. So this will be your development rate. Again, a 1 mark question, but yeah, slightly conceptual. Clear? So your answer will be 38.68. Fine. Okay. Now the last question, but now this one is a bigger question. A doubly reinforced concrete beam is given to you. Width is 300 mm given. Overall depth. So width is given as overall depth is given 600 mm. Then it has told you two number of bars are there, 25 mm in your tension side and two bars of 16 mm is there in your compression side. Table is given to you and effective cover to compression also, and for tension steel for both it is 40 mm. So it is asking you the moment of resistance. Now let me add slides. Till then, if you want, you can solve it. I'll add slides to it. Okay. First, I'll draw the diagram better. This 9. Clear? Till here, anybody is having any doubts? I've just drawn the diagram. I've done nothing else. Anybody? I'm seeing it. Anybody is having any doubts can comment. Anybody? Okay, fine. So first we will calculate the area of steel in tension, the area of steel in compression, the basic thing. So area of steel in tension 2 into pi by 4, 25 square. Area of steel in compression is 2 into pi by 4, 16 square. So 981.747 it is coming. So we can take 75 mm square. 402.1238, so we can take it as 402.12 mm square. And XU limiting, since it is Fe415, XU limiting we will take it as 0.48 D. That is 268.8 mm. Okay, now we have calculated all those things. Now we have to calculate this, since they have given you the ratio of D dash by D. Corresponding to that, we have to calculate the stress FSC. Okay, so D dash by D we have to calculate. So D dash is 40. D is effective depth is 560. So 560. So 40 by 560 will come out to be how much? 0.071428 it is coming, so we'll take 0.071. Okay, now we have been given the values here, so I have to do what? I have to do interpolation and I have to calculate FSC. Now can you guys do the interpolation and tell me the values? See, interpolation you need to know this. You might have done it in your steel and all, because even in your semesters and all, you read this one, select the most ideal sections of I-beam and all those things. So you need to do what? You need to do what? You need to do interpolations there also. Anybody? Okay, so it is 355 minus. We'll take 355. So 3.10 minus 0.05 into 0.071 minus 0.0. Now I'll calculate 355 minus 355 minus 3. 53. 354.16. 354.16 Newton per mm square. Okay. Now, in the question, it has asked me what to calculate moment of resistance. Now, everything we know, we have to calculate the moment of resistance. Can we calculate the moment of resistance, guys? Can we calculate? Simple, now just you have to apply the formula, that's it. Nothing you have to do it. We'll calculate the limiting moment of resistance. Nobody has done it? Okay, fine. Now I'll be doing it because I have to give the gate weapon, right? You don't have to give it. This actually, this much you might already do, but the additional portion, you can take 0.45 FCK also, or if you want, you can take 0.446 also. That is up to you. Area of steel in compression, D minus D dash. Okay. Now 0.36 FCK, that is 415. Let me take it in first Newton mm, then I'll convert it into divided by 10 raised to power 6 and get it in kilonewton meter. Okay. Width is 300. XU limiting I have already calculated, 268.8. D is 560, right? 560. How much we got it? 354.16. Here it was FCK, I have written by mistake FI. While writing here, I realized it is M20 now. Okay. Area of steel in compression, I calculated how much? 402.12. 402.12. This is 560 minus 40. Yeah. Calculation of this in your virtual calculator, I'll advise you to calculate in parts first before the addition what is there, calculate this, and then after what the addition what is there, calculate this. So this will be easier for you to calculate. Okay, or I'll do this 0.36 into 20. I have to do it in this calculator, so it is easy for me. 268.8, 560 minus 0.42 into 268.8. Okay, plus 354.16 minus. This I'll divide it by 10 raised to power 6 also, so that I get directly in kilonewton meter. So 331.7826 kilonewton meter. So this is the C option. Correct. So in this question, I guess everything you know. Only thing which you don't know in this question is that you have to calculate. Here I'll write the limiting moment of resistance to be calculated. Okay. In this question, only thing which I wanted you to know that how to do the interpolations. So you know that it is coming between 0.05 and you just calculate the slope, multiply it, and that's it. Nothing else. Okay, so these were the 5 challenging questions with you guys, and I'll be sharing, if you want the PDF of it, then I'll be sharing my Telegram group in the comment section. Fine, I'll do it right now only, so you can access. So this is my Telegram group, so you can access to it, you can join it, and I'll be sharing the PDF there also. Previous 5 challenging questions on environment, I have shared the PDF. You guys can check it out. And this PDF also, I'll share it soon. Okay. So do let me know in the comment section if you want any more videos. And guys, you can download the Resultant app. You can go to the Play Store, search for Resultant Civil, install it and open it. Okay. Apart from that, you can follow us on Instagram as well as on Facebook. And that's it. Okay. Thank you, everybody. Take care of yourself. Bye bye. Good night and study hard. Thank you, everyone.